Hello, my name is Thomas Reiter. I'm an astronaut of the European Space Agency ESA. My home base is the European Astronaut Center in Cologne. Before joining ESA, I was a jet pilot with the German Air Force. In 2006, I spent 167 days on the International Space Station. I would like to invite you to visit the station with me. I will show you how the station looks like from the outside and the inside with the help of stereoscopic images. I left Earth on the 4th of July 2006 in an American space shuttle and arrived at the station 2 days later. Our shuttle docked at this docking port, which is mounted on the American laboratory called Destiny. Through the transfer tunnel, I then entered the space station. Now let us switch over from virtual reality views to real stereoscopic images that my astronaut colleagues and I have taken during my stay on the station. Welcome on board the International Space Station. This was my home for 167 days. The first room that you come in when you arrive with the shuttle is the American laboratory Destiny. Here we float from one end to the other. Alright, let's turn and float back. There are 3 European experiment facilities installed in Destiny. The -80-degree laboratory freezer Melfi, which is above us, and the European modular cultivation system that we pass now. And the microgravity science glove box, which we see here. These images were taken in November when there was no shuttle at the station. Therefore, the hatch which leads to the shuttle was closed and the commander used this place to store some of his shirts. The next element is the American connection node 1, which is called Unity. We float towards the hatch which leads to the Russian elements. Above the hatch you see 2 yellow traffic signs telling us that there is construction work on the space station and that the speed limit is 28,000 kilometers per hour, or expressed in miles, 17,500 miles per hour. As one orbit around the Earth makes about 40,000 kilometers, this speed brings us in 1.5 hours once around the Earth. Unity is quite spacious as compared to the other modules. That is why I can show you a full body flip. From Unity, we turn to the right to reach the Quest module. This is where the American spacesuits are stored. One of these suits I used during my extravehicular activity on the 3rd of August 2006. In the back you see the American airlock through which I left the station to work outside. Unfortunately, I could not take the 3D video camera with me during the extravehicular activity, so please let me take you on a virtual reality tour to the outside of the station. I left the station through the American airlock in Quest that you see here in front. I prepared the ISS for the arrival of new solar arrays and laboratories. I also installed experiments on the truss.
When
my ESA astronaut colleague, Christa Fuglsang from Sweden, joined us on the ISS, he did 3 EVAs in order to electrically connect the new solar panels and to retract and fold the solar panels that have been operating on the station for 6 years. Actually, Christa and his fellow astronaut, Robert Kirby, had to manually unblock the solar panels when they would not retract automatically. Now let's get back inside and move further. We are now in the Russian Zarya module. We use Zarya as a washing room. There is not much luxury, just the mirror that you see here on the right wall, a water dispenser and some towels which we wet to clean our body. There is unfortunately no shower in the space station. However, the main purpose of Zarya is the storage of spare parts, food reserves, clothes and other important things. Through the open hatch of Zarya, we see the Russian Zvezda module, which will be the next destination on our tour. Now we are entering into Zvezda. Zvezda means star in Russian. This is where we spend a lot of time. Here is a large dining and working table, and there are 2 sleeping cabins. Between the dining table and the sleeping cabin of the commander is a locker for food storage. The blue boxes contain US food and the red boxes Russian food. Of course, we eat both types of food, independently from our nationality. Fortunately, we also had some European food on board the station. Here is the control post for all the Russian station elements. From Zvezda, all incoming Progress spacecraft can be remotely controlled during their approach and docking. We have a lot of tools that we store in Zvezda. Most of our photo and video cameras are also attached to the walls. Zvezda also has a cabin with a toilet for the whole station. Here you see the toilet seat. Now let me demonstrate some nice stereoscopic effects at the working and dining table. Here's the crew patch with the logo of the Astrolabe mission. During this mission I performed more than 20 experiments for scientific research, education purposes and the test and demonstration of new technologies. The camera was developed by ESA's Erasmus Center in Noordwijk. It allows you to get a better idea how the station interior looks like. You have already seen that it looks quite complex and dense inside the station. With stereoscopic views, it is easier for the people on the ground to understand the situation on board. Here's a small demonstration of foldable geometrical structures in weightlessness. This was done by one of my sons who made it out of drinking straws to show weightlessness to school children. Although 3D images are very useful to bring the station closer to the eyes of the European citizens, the main purpose of this stereoscopic imaging technology is, however, to create up-to-date virtual reality models of the station which can help the mission controllers and support engineers on the ground to know what is where on the station and to better design new experiments and their integration into the existing environment. Like all my colleagues, during my whole stay on the station I never got tired of watching our beautiful planet. There are views which are really breathtaking. Here you see the reflection of the sunlight on solar panels just as we fly into sunset towards the night side of the orbit. We can see 16 sunrises and sunsets within 24 hours. But an even more breathtaking view is the one from outside the ISS while doing an extravehicular activity. This is the Russian spacesuit called Orlan. It is similar to a suit I used during my extravehicular activity 12 years ago on the former Russian space station Mir. Here you can observe the reflection of the stereoscopic video camera in the helmet of the EVA suit. From the windows we can also enjoy the very nice view of company approaching. This is a view of Space Shuttle Atlantis during its approach to the station on the 11th of September. About 100 meters away from the station, Atlantis performed one turn around its lateral axis so that we could inspect its outer surfaces for possible damage through the station windows. This maneuver took place while the station and the shuttle were passing over Spain at an altitude of approximately 350 kilometers. Just a few minutes later, we had reached the Mediterranean Sea, flying over the coast of Sardinia, which you see below. Now let's go outside again to see where the crew of Atlantis attached a pair of new solar arrays to the truss, which increased the amount of electric power that is available for the station from 30 to 60 kilowatt. This was important also for the arrival in late 2007 of the European Columbus Laboratory. Space Shuttle Atlantis and the crew stayed 1 week with us and then returned to Earth. They made room for the arrival of a new expedition crew who relieved the expedition 13 crew members, Jeff and Pavel. They had arrived to the station already in March 2006 with a Soyuz TMA-8 spacecraft, which you see here docked to the docking port on the Russian Zarya module. This is one of the 3 docking ports which are available on the station for the Russian Soyuz and Progress resupply spacecraft. Zarya, which we are now floating by, was the very first element of the station launched into orbit. A second docking port for Soyuz or Progress spacecraft is on the Pirs module, which now comes into view. In our virtual reality simulation, this docking port is empty. When I came to the station, Progress M57 was docked here. Pirs is attached to Zvezda and it has an airlock for astronauts who are wearing Russian extravehicular activity suits. The third Russian docking port is at the rear end of Zvezda. This is where the new Expedition 14 crew arrived with their Soyuz TMR-9 spacecraft. While we are flying over Europe from Spain to Cyprus, yet into another sunset, I would like to take you back inside to introduce you to the crew who joined us in September. The new crew included the first female spaceflight participant visiting the station, Anusha Ansari. When a new crew has come on board, it is a good Russian tradition to make a live video conference with the Russian Mission Control Center in Moscow and to congratulate the crew to their successful arrival. This is a short scene from this ceremony. Both astronauts have a military background like me. That is why they wear their military caps for the welcome ceremony. In the back of the group you see my NASA colleague Michael Lopez Alegria. He and Mikhail Turin on the right replaced the Expedition 13 crew members, ISS Commander Pavel Vinogradov and Flight Engineer Jeff Williams. Together with me, the two new astronauts formed the Expedition 14 crew. Michael Lopez Alegria was the new commander. Mikhail Turin and I were the flight engineers of Expedition 14. For 9 days we were 6 persons living and working on the space station. This is how crowded it looks with so many people on board. We start in the American Destiny module, where we pass by Jeff Williams and Michael Lopez Alegria. In Unity, we meet Anusha Ansari, who is processing her email. And now we float through Zarya, and this is how a nice roll maneuver looks like. We arrived at the aft end of the station in Zvezda, where we meet Pavel Vinogradov and Mikhail Turin. Alright, now you have seen how crowded the station often looks like and how packed it is with equipment. Thanks a lot for joining me on this tour to the ISS. I will leave you now and get back to my work at ESA's European Astronaut Center in Cologne. All the best to you and goodbye.